Class number 8, System Direction Field, Second Order Linear D. Linear D, So systems of DE. What is systems of DE? It is more than one equation of DEs. So it is called a system of DEs. Okay. So for example, suppose I have 3 interconnected tanks, pure water, mixture, and the situation is construct a mathematical model for the number of pounds of salt xt, yt, zt at time t in tanks A, B, C respectively. So if we look at the tank A, pure water comes in at 4 gallons per minute and it goes out at 4 gallons per minute, and there are 200 gallons of water. So for the amount of salt in tank A is xt, B, yt, C, zt. So the rate of change in the pounds of salt per minute, so that's pounds per minute, is rate in minus rate out. So how much are coming in? 4 gallons per minute. So 4 gallons per minute of pure water. So in 1 gallon, there are 0 pounds of salt. So gallon disappears, I get pounds and minute back, right? So that's what is coming in. And what's going out is the following. So it is going out, mixture is going out at the rate of 4 gallons per minute times in how many gallons of water? Well, it comes in at 4 and it goes out at 4, so the amount of water will stay as 200 gallons. So that's 200 gallons. But how many pounds of salt are in there at t time? At time t, there are xt pounds. Okay, so we get, for x we get dx dt equal to minus 1 over 25x. If we simplify, made a mistake here. I'm sorry. It is 50, yeah? Sorry. Similarly, let's look at y. So for y, dy dt, again, pounds per gallon is rate in minus rate out. So rate in, 4 gallons per minute of mixture is coming into B. So it is 4 gallons per minute where there are, it comes from here, right? So there are 200 gallons, and in that 200 gallons, xt pounds of salt are there. So we have pounds per minute. Yep, that's in. And what goes out is, this is what goes out. So it goes out at 4 gallons per minute. So it is 4 gallons per minute. And in how many gallons? Well, it comes in 4 and it goes out at 4. So there will be constant 150 gallons. So it is 150 gallons. And at time t, there are yt pounds of salt. Okay, so for y we get dy dt equal to 1 over 50x minus 2 over 75y. So that's for dy dt. And for z, let's do a similar thing for z. So dz dt is right in, comes at 4 gallons, right? So 4 gallons per minute. How many gallons? It comes from here. So 150 gallons. There are YT pounds of salt. And what goes out is, it goes out at 4 gallons. So 4 gallons per minute times how many gallons? It comes in at 4, it goes out at 4, so it'll be constant 100 gallons. So 100 gallons where there are CT pounds of salt at time t. So if we simplify, dz dt equal to 2 over 75y minus 1 over 25z. Okay, then I have 3 d's where each share same unknowns. They share common unknowns, right? So we call the system of d's a system of d's. So we have this system dx dt equal to minus 150x, dy dt equal to 1 over 50x minus 2 over 75y, dz dt equal to 2 over 75y minus 1 over 25z. So how to solve such a thing? It will be in the differential equations 2 class. So in this class, we only do setup. Okay. Now the direction field, or it is called slope field, because if we have a first order dE, suppose it is something like this, yeah, and then we have initial value, suppose, yeah. So this is your f of t comma y, right? So if I know that this is not linear, not separable, not exact, and there's no integrating factor q, t, or ry, and if the substitution doesn't work, so all the methods that we learned, if that fails, the last thing that we do is graph it. Okay, so how do we graph it? Graph y. How? Well, this tells you the slope, right? So you're gonna pick random points t, y, plug that into the function, and get the slope there. So what I mean is, so in the ty plane, ty, so for example, if t0, y0 at this point, then sine 0 will be 0, So that means slope of y dy dt is 0. So we draw a little arrow. At 0 it is slope 0. And for t equal to pi over 4, so that is approximately 0.75. So put that to t, and we can pick y as 1 randomly. So y equal to 1. So compute sine of 1.75. That will exist. It will be a number. So that's pi over 2. That's pi. So it will be somewhere here. So it's a number less than 1, some positive number less than 1, right? So at the point t 0.75 y1. So let's say that is t pi over 4 y1. At this point, my slope is sine of 1.75 approximately. So it is some positive number less than 1. So slope 1 is exactly this, diagonal. So it is less than 1, so it is somewhat like this. Somewhat flatter than 1, but positive. Right? So, yeah. Pick a random ty, and then put that point t comma y into f, compute the slope, compute the function value, that will be the slope, dy dt at that point, and then you draw a little line segment. You can do this by computer. Okay, so in this class I am not asking you to draw it by computer. The direction field will be given to you, and then you will have to draw approximate graph of y. Okay, so all these arrows will be given to you. So if it is given, then what you do is, so suppose I have dy dt equal to f of t comma y, and I have this direction field. Then you will just follow the arrows, and then draw a rough graph of the function of y. So that's approximate graph of your solution y for this. Okay, so you can draw many, right? Following, there are infinitely many. But if we add in the initial value, suppose y0 equal to 0, then out of these, which one do you have to pick? Yep, you have to pick the one that goes through the origin, right? So you will pick this as your approximate graph of the solution to the IVP. So that's the method behind direction field. So if everything fails, draw a rough sketch.